Good morning, dear students. Now, in the present situations, we are at home and you are also at home, and our study should not be intervened by that situations. Keeping in mind, I am trying my best to cover up the syllabus of the chemistry as per the splitting of Kendra Vidyalaya Sangathan. I try to develop a chapter of chemistry, that is Unit 2 solutions. Now we have heard the name of the solution right from the beginning, and what is solutions? So for that we take a simple example. You take the simple example, we take the glass, and in glass there is some water. Now we pour some amount of salt in that water. Now we stir the water very well, and it will consume what we call it. We stir it very well, and we see at the bottom of the glass is any residue is left. If it is, we see and say no residue is left, and the solution is transparent, that it can be seen from this side to that side. So this is a solution. So this solution contains the two components. One is the solute, and here the solute is, that is the salt, and which was added in a small amount. So keep in mind, solute always in small amount, and when we put into the water, and that water is a solvent and it is in large excess amount, these together form a solution, and these solutions are maybe homogeneous and maybe heterogeneous. So here the solution formed is called the homogeneous solution, because there is no distinct boundary of separation between the solute and the solvent. Now we take another example for that. We take another glass, and what is in that glass? That we take some water in that glass. Now what we are doing it? We take some oil. So this is the oil. Now we put oil in that glass. So we stir it well. We stir it well. So, and we left for some time, and we see that the white droplets is at the upper side of the liquid. So this is not homogeneous. These components are not completely mixed up, and that solution is called the heterogeneous solution. So this is the introduction regarding the solutions. Now in our syllabus, there are so many types of solution. So types of solution is classified as the gaseous solution. This is the liquid solution, and the solid solution. And there is another component is solute, and another is the solvent. And here is the example. So this solid, liquid, gas, and these all are gases, gas. Solid, liquid, gas, and these all are gas. This is a liquid, and a liquid. So the example is listed in the NCERT book, page number. The table is in the book, that is page number 34 and table number 22. Table number 2, 1, page NCERT. CERT book, that is 47. That we can note it. That is page number 34. So we see the so many examples given in the table, listed in the table. So now another we now we take another components of the solutions. So what we our objective in that chapter? What are the objective? First we have to know about the methods of expressing the concentration of the solutions. Another one, there is some related law and the numerical based on that law. And there are the learning objective, that is ideal solution and non-ideal solution. So we take it a step by step. So our first is the methods for expressing the methods for expressing the concentration of a solution. First one is mass percent. So mass per percent is defined as, that is WA plus WB multiplied by 100. So this is the mass percent, means mass of a component present per 100 part by mass of solution. Now here the solution is constituted by making the two component WA and WB. So what is WA? WA is the mass of the solvent and WB is the mass of the solute, as we discussed in the earlier. Always we consider the solute as designated as B and solvent as A. So if you take the example 35% by mass, what does it mean? It means to say that 35 gram of solute present in 100 gram of solution. That is 35 gram of the solute present in 100 gram of solution. Now another is volume percent. Volume percent. This is the VA plus VB or multiplied by 100. That is volume of a component present per 100 part by volume of solution. That's it. 45% by volume means 45 ml of the solute present in 100 ml of solution. So this is known as the volume percent, right? So we taken as the third one. Third one is a part per million. Part per million. This is mass of a component, total mass per million part of solution 10 to the power 6. This is called part per million. What is the use to take the part per million? Because part per million is very important factor, because all the pollution figure is expressed in ppm. Suppose the example is given in your book. A liter of the seawater which have weight 1030 gram contains about 6.3 gram of dissolved oxygen. Calculate part per million. Now we calculate for that the mass percent. We calculate for mass percent. Mass percent for the oxygen, dissolved oxygen, mass of a component 3, total mass of the seawater, that is it is given 1030, and this is mass percent 100. So when we calculate it, it comes to be 0.00058 gram. Now if we express it in ppm, in ppm, then it comes to be 6 multiplied 10 to the power minus 3, 1030 into 10 to the power 6. So it comes to be 5.8 ppm. So it is given in your book how to express what is the utility to express the concentration in part per million. Part per million is defined as the mass of a component present per million part of solution. Mathematically, it can be expressed as WA, that is mass of a component. Here we taken as the mass of the dissolved oxygen, that is 6.10 to the power 5, and the total mass of the seawater. Seawater will contain so many components, so we taken here the total mass, and mass percent calculate per 100, that's why 100 it comes to be kilogram, and this is. So this is very, very small. We are not able to express such concentration in mass percent. That's why it is very efficient to express the concentration in terms of part per million. Now we come in another, that is number 5. So number 5, mole fraction. This is mole fraction, and this is represented by X. This is represented by X. So we consider let the two components A and B. Now WA and this is WB. As per our concept, we always consider the B as the solute and A is always solid, right? Now MA and this is MB. Now this moles, let moles is equal to NA, NB, NA, moles is equal to NA and LB, NB. So XA is equal to NA by NA plus NB. Now we defined the mole fraction now as what is number of moles, or it is the ratio. It is the ratio of number of moles of one component to that of the total number of moles. This is the mole fraction. If Na is the number of moles of the solvent and Nb is the number of moles of the solute, consider it as solvent and consider it as solute, then the mole fractions of the solvent, that is Xa is equal to Na plus Nb. Now similarly हम लोग उसी तरह से ले सकते हैं mole fraction of the that is solute. This is Nb and this is Na and this is Nb. This one is Nb. So the mole fraction of all components, suppose there are so many components, then what is the sum of mole fractions of all components? So this is Xa plus Xb, and that is equal to if we sum up and it comes to be 1. So if Xa barabar now 1 by 1 minus Xb. So if the mole fraction of one component is known, the other components can easily be calculated. Now, so there is a problem. When we go to the theory, then there is some numerical problem. So we can find to the numerical problem, and it is given in page number 36. Page 36, and problem number 2.1. Problem 2.1. So you see, calculate the mole fraction of ethylene glycol C2H6O2. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H4O2. So we read the question again. Calculate the mole fractions of ethylene glycol C2H6 CO2 in a solution containing 20% of ethylene glycol. Ethylene glycol is CH2OH and this is CH2OH. So the formula is correct, C2H6O2. So calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2. So how we will calculate it? For that there is a theoretical concept already given here. So we apply in the same concept. Now 20% ethylene glycol. What does it mean? The mass of solute. That is 20 gram. And mass of solvent 100 minus 20, that is 80 gram. Now if ethylene glycol is the solute is C2H6O2. So we calculate the number of moles of C2H6O2. So it comes to be 20 by, what is the molecular mass? So we have the concept to calculate the molecular mass as we know in class 11th and 9th also. So there is a simple way to calculate the molecular mass. 2 into atomic mass 12 plus 6 atomic mass 1 plus 16 into 2. So that is 24 plus 6 and plus 32. So it comes to be almost that is exactly 62. It is exactly 62. It is exactly 62 gram per mole. So 62 gram per mole. This is the number of moles, molecular mass of this is the ethylene glycol. Now this one is 62. Now we divide it. Now water, now solvent is 80 gram. So number of moles of water we take it here. Now this is the weight 80 and this is 18. So we calculate the number of moles of water also according to the formula, because Na plus Nb like that of, if we water is taken as A, that is weight by molecular weight, and if ethylene glycol is taken as Nb, then weight by molecular weight, this will comes to Na plus Nb. And ethylene glycol, so mole fraction of C2H6O2 is equal to how much? Number of moles on solution it comes to be, when it is solved it comes to be 0.322, and when it is solved it comes to be 4.444. So we put here the number of moles of C2H6O2 by number of moles of C2H6O2 plus NH2O. We put the value and solve it. We find the mole fraction of the ethylene glycol. Right? Now, the another want to know, then we take the another, that is methods of concentration for expressing the concentration of the solutions. This is our topic. So we take another one is molarity, and I hope molarity, that is capital M. This is a molarity. In class 11th we already have the knowledge of the molarity, number of moles of solute present per liter of solution. So mathematically it can be written as Nb by volume of solution in liter. This is where Nb is the number of moles of the solute. So we can write is number of moles of solute volume of solution in liter. So this is called the molarity. Now, if we write the mathematical expression, so that mathematically it can be expressed as NB by volume of solution in liter. Now, where NB is the number of moles of the solid, so it can be written as weight by molecular weight, and this one is volume of solution in liter. Now, so its unit will be moles per liter. Now, if volume is in milliliter, then it is this one MB, and this is V in milliliter. This is V in milliliter. So this is the mathematical expression for the molarity. Mass of the solute present per liter of solution. Now one thing asked here. So this is the molarity equation, is also some, that is M1 V1 is equal to M2 V2. This is M1 is the molarity of the one solution, V1 volume of the one solution, M2 molarity is the second solution, and the V2, that is V2 is the volume of second solution. There are 4 parameters here. If the 3 parameters are known, the 4th one can easily be calculated, right? So what is the effect of temperature on molarity? Effect of temperature on molarity. Effect of temperature on molarity. So the expression is very clear. That is mass W. This is volume in milliliter, or this is 1000. This one. Now, when we increase the temperature, then what will happen? Volume will increases. Generally, the student think the volume decreases, but this is our misconception. When we increase the temperature, the intermolecular force between the liquid will become weaker and weaker, so that the volume of the solution will expand. So volume increases under what condition? When temperature increases, volume increases. Now volume is the denominator. Now if volume increases, the molarity decreases. So we can say M is inversely proportional to T. And on increasing temperature, molarity of the solution decreases. Now to get the concept clear, we take an example. This molarity. So again, in the problem number 2.2, page number 36, calculate the molarity of the solution containing 5 gram of NaOH in 450 milliliter of basis. And what is? Find out molarity of a solution containing 5 gram of NaOH in 450 milliliter of solution. Right. So this is how we'll go to the problem. So we have the knowledge of the mathematical expression. It is always written here. This is the molarity expression. How we will solve this problem? First, we write the data from the equation. Here, find the molarity. We have to find out molarity. M is what? Of a solution containing 5 gram of NaOH. Now, NaOH is a solute. Similarly, we have taken this water and water. So this is a solvent. Now 5 gram of NaOH solute. NaOH is a solute. It is dissolved into that water. So question is asked, what is the molarity of that solution? This is. So we take This is weight of the solute as our concept, that is 5 gram. Is that clear? Now the NaOH molecular mass, this is Mb, this is for NaOH. So again we have the concept of the molecular mass calculation. NaOH, Na is 23, oxygen is 16 and hydrogen is 1. So it comes to be, that is 40 gram. 40 gram. Now what is the mass of the, that is solution volume? V in milliliter, that is 450 milliliter. So we put this into that formula. This is the formula. Weight 5 by 40 into 450, and this is 1000. And anyway we put it and write its unit mole per liter or capital M. So this is all about the molarity of the solutions, and there are so many related problems we can find. Now another, the concept how to express the concentration of the solution. Another one is molality. This is molality. Molality. And it is always represented by small m. Molality. This is number of moles of solute, number of moles of solute present per kg of solvent. Present per kg of solvent. Number of moles of solute present per kg of solvent. Now, so this is a M. So it is number of moles Nb, and per kg of solvent W, A mass of solvent in kilogram. This is the mathematical expression. Number of moles of solute always be considered as B. In your book it is considered as N2. N2 is considered as the number of moles of the solute. Whatever be the concept, whatever be our assumptions to consider the solute and the solvent, it will depend upon yourself or upon me. That is number of moles of the solute and WA mass of the solvent in kilogram. If the mass of solvent, now it can be elaborated as WB, MB, and this is WA in gram, then it is 1000. That is, what is the unit? Mole per kg. What will be the unit? That is mole per kg. This is mole per kg. This is mole per kg or m. What will be the value? Find out numerical value. We write it unit. So we should have the concept of the unit, because unit is the measure factors. With numerical value, unit, that is mole per kg. Now, what is the effect of temperature? Effect of temperature. Temperature. Is molarity affected by temperature? We say yes. And what will happen? On increasing temperature, volume increases, hence the molarity decreases. But in molarity, not affected. Not affected, because it is mass to mass ratio. Mass to mass ratio. So there is no effect of temperature. So we write here not effective. Now, so there is one problem related on it. This is a molality problem. And this is a page number. This is page number 37 and problem number 2.3. Page number 37 and problem number 2.3. Page 37 and example 2.3. Now the problem is, calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. So first I write the problem here. Calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Benzene, 75 gram of benzene, right? Now attempt. How will steps? How? What is first step? Write data, write value. Second step, write formula. Third step, put the value in formula. And fourth step is solve it. That is solve it. So how we will write the value? It is the technique. And then how to write the value? The 2.5 gram of ethanoic acid. It is in less amount, so it is solute. So WB 2.5 gram or solute. B considered as the B, and this is the mass of the solute. It is represented as WB. So 2.5 gram. Now this is the ethanoic acid. This is ethanoic acid. Write the formula, value the WB, and it is dissolved in 75 gram WA. This is mass of solvent WA, right? Now this ethanoic acid, so we have the concept and we should have the knowledge to write the ethanoic acid. This is CH3COOH. This is. Now we calculate the molecular mass. So what will be the molecular mass of this ethanoic acid? That comes to be 12 plus 3 plus 12 plus 30. There are 2 oxygen plus 1. Almost it comes to be 60 gram per mole. 60 gram per mole. That comes to be 60 gram per mole. These are data. Now what we have to calculate? M. So M, this is formula. Now write the formula. Now formula is MWB MB WA in gram, and then it is 1000. Because as per our formula, when the mass of the solvent is given in gram, then we multiply this here, that is 1000. So now put the value in the formula. This is 5 gram, and the molecular mass of this is MB. If the solute is WB, then its molecular mass will be MB, and it comes to be 60. And then mass of solvent, it is in gram, 75. So here we put 1000. Now on solution we get the result, and we write moles per kg. This will be the solutions of this problems, right? So what we see, what is our learning objective today? And we start from the solutions. What is solutions? What are the components of the solutions? We know it, there are 2 components, that is solute and the solvent. And these combined together form a solution, and we get an idea what is the homogeneous solution and what is the heterogeneous solution, and what are the types of the solutions. That are the gaseous solution, liquid solution, and solid solution. And that will depends upon the medium of that is solvent. If solvent is liquid, then it is liquid solution. If solvent is gas, then it is gaseous solution. If solvent is solid, then it is in a solid solution. As examples are given in the book, and it is our this is your topic of home study. Now we get an idea about the methods for expressing the concentration of the solution. So first we explain what volume mass percent. Suppose 45% by mass. What does it mean? That is, as for example, 20% of ethylene glycol. What does it mean? Means 20 gram of ethylene glycol present in 100 gram of solution. And this is solution. This is solute, and this is solvent. This constitute to give solution. So solution if 100 and solute is 20, then mass of solvent can easily be recorded. So the volume percent or the mass percent, these are very useful things to calculate the mass of the solvent. We should have the clear concept on that topic. Now again we consider the volume percent, then we calculate, we explain today the mole fractions. What is the mole fractions? And the numerical problem based on the mole fraction. Then we explain the molarity and what is the effect of temperature on the molarity equations as per our syllabus. Then we have explained the molality, what is molality, and what is the effect of temperature and molality, and the problems based on molality. Today's topic is this. Now I want to discuss the another things, that is the solubility and the related law, that will be explained in the another classes. Okay. Thank you for your presence listening, and I hope sure that you will go through the book and do the same things at your home, so that you will get benefited from this audio lectures. Thanks a lot.